In this video, we are going to learn how to make a moving platform. Our platform is going to move from point A to point B, back to point A, and it's just going to keep ping-ponging between those two locations. Our player will be able to jump on this platform and ride it. It can move in any direction, and we are going to try and make it as customizable as possible. We're going to make it so we can customize the start point, the end point, the material used, the mesh used, as well as the speed of the animation. And the reason we want to make all this customizable is so we, as the gameplay programmer, aren't making decisions on how this platform is going to act in any specific level. Instead, by making it customizable, our level designers can be the one to make these decisions and do whatever is fit for their level design. We just want to give them the options. Just like you guys have probably used modular art assets while creating your levels or creating your environments. We want to strive to make our code as modular as possible so that our level designers are the ones making decisions on how they act and not us, as we don't know what levels they want. The more modular we can make our assets, the more possibilities that opens up to the level designer and the more freedom it gives them. And just one caveat before we get started, just like the other things we have made, this isn't the correct way to make this. There is no correct way. There's only trade-offs. So I'm going to be focusing on a fairly simple way to make our moving platform. You might realize there are certain things our moving platform doesn't do, it can't do. There's limitations to it. And obviously you can improve on it. But I just want to show you a simple way to get started, get it working. And again, once you make this, you might find improvements you want to make, and that's a good thing. So let's get started. To get started, I'm going to make a new blueprint actor for our moving platform. I'm going to make it an actor class and call it BP moving platform. So just to start, I'm going to use a box or a cube, sorry, for my moving platform. And I'm just going to vaguely scale it to some moving platform proportions. There you go. And now let's just get this platform to move. Let's make that our first goal. To get it to move, I'm going to use a timeline and a new node called a lerp node. So let's take a look at this lerp node since it's new to us. I'm just going to go to the event graph and I'm going to search lerp. And so you can see the lerp has a return value. It has an A, a B, and an alpha. So let's just take a look in Paint as to how this lerp node kind of functions. So we had an A value, a B value, and an alpha value. We can think of A and B as like start and end points. And we can think of our alpha as like what position we're going to be in. So the alpha goes from 0 to 1, with 0 being at A and 1 being at B. So I'm just going to use an example. Say our A was equal to 1 and our B was equal to 100. If I was to draw this out on like a timeline, we would have a long line that goes like this, starts at 1, ends at 100. And our alpha will control what number is given to us. So we had a return node. Our alpha is going to control what number is given back to us based off of it. So for example, if the alpha was equal to 0, then the output would be at 1 because that's our A. So when we're at 0, we're going to be at 1. If our alpha was 1, which is the maximum our alpha can be, remember it goes from 0 to 1, then the output would be 100 because that is the other end of the scale. If our alpha was something like 0.5, which is halfway through the scale, then our output would be equal to 50. So wherever the alpha is between 0 and 1, it's just going to move itself along this timeline, or this number line, sorry. And the way we can use this now is we can set our A as our start point, our B as our end point, and we can animate a timeline that goes from 0 to 1, which means as the timeline updates, it starts at 0, and then as the frames go up, it goes up in value, which means our output goes up in value all the way towards our B value. And then we can animate our timeline backwards. We can make it go from 1 back to 0, which will do the same thing. It'll just make it go all the way down very smoothly, frame by frame. This is how we're going to use the alpha to animate our location. Let's take a look at that. So I'm going to delete this this lerp node. As you can see, these lerps take a float, but Unreal has a special lerp node for vectors, which is what we're going to use. So I'm just going to search lerp, and you can see in parentheses it says vector. That's one we want to use. It takes the same thing. It takes an A and a B, a start and an end. We can think of it like that. And an alpha, which is just a number between 0 and 1. I'm going to add a timeline. I'm going to call this platform move. I'm going to add a track and call it alpha, because that is what I'm going to be setting with this. So for now, I'm just going to set my timeline's animation to 1 second. And I'm going to add three keyframes to it. I want my first keyframe to start at 0 seconds and be a value of 0. I want my second keyframe to be at 0.5 seconds and have a value of 1. And I want my third keyframe to be at the end and back to 0. And so if I set this timeline to loop, what we have here is we're going to start at 0, go up to 1, back to 0, and then because we loop, go back up to 1, back down to 0, loop, back up to 1, back up to 0. So we're just going 0, 1, 0, 1, 0, 1. Our alpha is just going up and down. So let's use that to see our platform animating. So I'm just going to start it at world 000, and let's make it move to 1000, 1000, 1000, 1000. Plug the alpha where it needs to be. And before I actually get it to move the platform, as usual, let's see it on a print string. Plug the update in here, the return value, and make sure to give it a key so that it doesn't keep printing. I'm just going to call it pose for position. So let's save this out, and let me drag my BP platform in here. And now when I run it, you can see the value is going up towards 1000, back towards 0, up towards 1000. It's only taking 1 second, so it's happening fairly quickly. And so to get this to work, really all we need to do is plug it up into our actor's location value. So I'm just going to do set actor location and plug this into it. So now this is going to move very quickly. If I was to run it, there it is. And it's moving very, very quickly. And this isn't ideal for us because we want to be able to control our speed for the thing, and I don't want it to be this fast. Now, I could change the length here, but if I did change the length here, for example, if I made this 5 seconds, you can see that I need to re-change my keyframes. I would need to make this go to 2.5, and I would need to make this go to 5, which again, not ideal because I want to be able to give my level designer the option of controlling this time. I don't want to be the one to do it. So let's do that real quick before we continue working on this moving platform, because I feel like that's fairly important for us to even visualize this moving platform. So to do that, let's make a variable that our level design can use. I'm going to call it custom duration. I could just call it duration. And let's set that to a float. Let's compile it. Make sure that this float is instance editable, so they're able to edit it. And now, if I could bring up my paint again. The formula that we're going to use for setting our custom length is going to be the play rate. So this is what we are going to set in our timeline, is something called the play rate. And that is going to be equal to the original length, which in our case is 1 second, divided by our custom duration. So this is the formula we're going to use. We're going to set something in the timeline called the play rate. We're going to divide the original length, which is 1, by whatever our custom duration is. So let's do that. Let's go back to Unreal. And I'm going to do this on begin play. I'm going to take our custom duration. And I'm just going to do a divided node. And I want to divide 1, which is our current duration, by this custom duration. And so where do I set this? When we made this timeline under our components, it gave us a timeline asset. So we can drag a reference out to that, and we can do set play rate. And we just want our new rate to be this. So here I can take this custom duration, and instead of 1 second, I can make it 5 seconds. Now when I compile and I was to run this, you can see our platform is moving much, much slower. It's taking 5 seconds now. And the 5 seconds, by the way, is to go back and forth once. So if you wanted it to take 5 seconds just to go in one direction, you would need to set your play rate to 10, which, because I made it instance editable, I can now just directly do it here. I can change this to 10. And now when I run this, you can see it takes much longer. It's going to take 5 seconds to go in one direction, 5 seconds to come back. And if we were to just play our game and run to our platform and hop on it, it works. That's pretty much really all we needed to get the moving platform, was to get our timeline, lerping it, and set the actor's location based on it. But we can do better. Right now, it doesn't matter where I place this actor, because I am hard coding this lerp value. I'm hard coding it to be 000 to 1000, 1000, 1000. And I don't want this. It's actually better that we let our level designer set these. So let's do that. What I want for where it starts is just wherever they place the actor. So the start location is going to be where they place it. And I can do that by just get actor location. And I want to set this to a variable. So I'm going to do that. I'm going to make a new variable, call it start location. And on begin play, let us set our start location to where we start. And instead of using this 000, I can just use my start location. So it's still going to end at 1000, 1100 in the world, but now we can see when I run this, it's going to start from wherever I started. So it started from here. If I move this asset somewhere here and run it, it starts from there, and it's going to lerp to the end position. Let's get the end position customized. So instead of using 1000, 1000, 1000, I'm just going to make a new variable, and I'm going to call it end location. I'm going to make this variable public, so it's instance editable. And I'm going to make sure to check on show 3D widget, because this is going to let us use a 3D widget to position it in the level rather than typing out the numbers here. And so that's a great way of doing that. I'm just going to move it to 100, 100, 100 so we can see the widget and it's just not on top of our asset. And we'll set the lerp's end location to that. Now we can see over here there's an end location. Oh my, there's an end location variable, or an end location little visual that pops up with a widget attached to it. And I can move this widget around. When I hit play, this isn't exactly going to work. One problem here, you can see my end location is moving with the platform. And so it's not being set correctly. And the reason for this is our end location is actually positioned relative to our asset. So when we look at the end location and we see something on it, it is actually relative to our to wherever our mesh is. So you can see it's at 0, 0, 0. That's really, it's actually at minus 2000, 1000, minus 0.5, because that is where my asset is. And even if I move my BP platform around, you can see that the end location doesn't change. So it is relative. So we need to convert this relative to position into the world position and then have our thing move towards that. It's fairly easy to convert relative position to world position. All we need to do is in begin play, we are just going to take our end location and we are just going to add it to our actor's location. And we set it back. And so now our end location should work properly. We can set it wherever we want. We can simulate the game. Okay, so that didn't work correctly. I was wondering why that didn't work, and the reason was pretty simple. I just didn't plug this value into end location. So that's all I really needed to do. And now we can see that this works. So you can see that my end location is just past these coins here. And if I was to play our game, our platform is going to move just past these end of the coins and it's going to move back. Okay, so that worked. The reason that it looked weird and I had to pause the recording was because I forgot to plug it in. And I just wanted to go back and check where that issue was. And it was as simple as I forgot to plug this in. So now we have a moving platform where we can customize the start location, we can customize the end location, and we can also customize the duration. So that's cool. It gives our level designers more power. But what if we wanted to let them customize the mesh and the materials as well? We could do that using these variables like we have. You know, we could just make a new variable, call it static mesh. Come here, make it sure it's of type static mesh. Object reference. And I could just make this instance editable as well. And in event begin play, we could set static mesh and set it to whatever mesh we want. So over here, for example, I could come here and make sure to set it to log wall. And then when I play it, it's going to replace this with the log wall. There's one big problem with this. When we're changing the static mesh, I want my level designer to be able to see the change. I don't want them to have to see a cube in their like wonderfully set dress level, and then only when they hit play are they going to see this log wall. They're not going to know how to scale it, how to rotate it, or how to move it very intuitively. So let's not set this in begin play. Instead, let's take this exact same logic of just making a variable and setting the static mesh, and let us do it in Unreal's a special function that Unreal gives us inside this thing called construction script. Now, all construction script does is, if you remember, we've talked about the tick event. The tick event runs once every frame. Well, if you think about it, our our viewport also technically runs once every frame. That's why I'm able to interact with it in real time. And so the construction script is just basically a tick event for the editor. It does not work when we play the game. It only works when we are in the editor. It runs once every frame. You saw when I hit compile, we can see that it runs. And so now, when we change the mesh, it automatically changes here. And that's very convenient because I can change it to whatever I would like. So if I was to make it a single log, if this thing had a collider, it should work just fine for us. And I made it a little too high to jump on, but you can see it has a collider, so I'm colliding with it rather than with whatever my box was. So this becomes very nice for our level designers. They can make it whatever they want. Let's also make the material customizable. For example, this coffee table static mesh I'm using actually has a material on it. it is currently not being used, so let's make sure to use that. So we would just make, just like we did the static mesh, let's make a material. Instead of it being type static mesh, it's going to be of type material. Let's compile this, and from our cube, instead of just setting the static mesh, we're going to set material. We could just leave it like this. This was going to set the material to none, and when the material is set to none, it's just going to use whatever our static mesh has assigned to it directly. So if I open up this static mesh, it has a materials just assigned to it, and so that'll work if it's set to none. But maybe you get, maybe your designers are using modular materials as well. So one asset can have 2 or 3 types of materials. In that case, we just plug in this material. So get material, set it. And again, right now that material is set to none. So it's not going to render that. But if I was to change this to something else, for example, you can see it's just going to use that material. I forgot to make this material public, but it's public and instance editable. And now we can see there it is in our level. We can see it in the details panel. And there you go. It's a fairly simple and quick way we can make a moving platform, but more than that, we have made this customizable. We've customized the speed. We can determine the duration of this animation or this movement. We can determine the end location. Wherever they place the model, that's going to be the start location. And we've given it a static mesh, and we've made it so we can customize the material on it. So I could change the material if I wanted, still use the same static mesh, but I could also just change the static mesh if I wanted. And if we clear the material, it's just going to use whatever the static mesh has, or I can set, my own material to it. So this way we have given the power from us to our level designers to do whatever they see fit. That has been a simple video on how to make a moving platform. Again, this moving platform has a lot of concessions to it. I can just show you one of them, and that is if I was to get in the way of the moving platform, ideally it should be pushing my character very smoothly, but we will see that it kind of doesn't do that. That is just one concession of this moving platform. There are ways around it, but that involves either rethinking how we did this or trying different ways, or we might have to add on to this. But this is a good start, a good moving platform that you guys can use to design your levels. Thank you for watching.